Hello, thank you for joining me. The question here says a non-uniform rod AB of length 2 meter is supported horizontally on two supports at A and B. The reactions at A and B are 60 Newton and 40 Newton respectively. Find the weight of the rod and the position it acts through on the rod. Now, for us to solve this question on moments, which has to do with equilibrium of forces, we have to first of all trace the diagram. We have to sketch the diagram first and see what we have there. So it says that a non-uniform rod, non-uniform means the weight does not act at the center. If it's a uniform rod, it means the weight acts at the center. But a non-uniform rod means that the weight does not act at the center. So for us to schedule, we are told that the rod is 2 meter long and it has two supports at A and B. So I can simply sketch this by ruling a horizontal line to represent the rod. And then we are told that it has support at A. This is the point A. And this is the point B. It has support at A and it has support at B. So this is a knife edge, which is the support or the pivot. Now, we are told that it is 2 meters long. That means from the point A to the point B is 2 meters. And then we're also told now that the reactions at A is 60. So reaction acts upward. So don't forget, reaction is an upward force. So at A, we have 60 Newton as the reaction. And at B, also an upward force, we have 40 Newton. And then don't forget the weight of the beam acts downward. So we don't know the position exactly because it is non-uniform. So we can place the position somewhere here. Let me just put it somewhere here. It is non-uniform. So let me say this is the position of the weight. And I'll call that weight W. And then the first question we are asked there, we are asked to find the weight of the rod. Finding the weight of the rod here is very simple. What we need to know when we have a balanced beam like this is to recall the fact that the total downward forces, let me use it as DF. The total downward forces is equal to the total upward forces. Let me use UF. So total downward forces, DF, downward forces, is equal to upward forces, total upward forces. Now, the downward force is the weight, W, that is acting downward, W, and it's equal to the total upward forces. You can see them, we have 60, that is the reaction, they are acting upward, 60 and 40. So the total upward forces will be 60 plus 40. And that will give us the weight of the rod as 100 Newton. So you can see that the weight is very simple to calculate in a situation like this. But what is quite challenging is the position that the weight is acting through. We don't know where it is acting, whether it's at this beginning or towards the end. We don't know the position of the weight because it is a non-uniform rod. So what we just need to do now is to take moment. But before we take moment, let's assume that the distance of the weight from the point A is X meters. So let's assume that this weight is acting at the distance X meter from point A. So now what we can do is to simply calculate the moment about one of the support. So let's take moment about the support point A, because we're already taking distance from this support A. So let's take moment about, when you are taking moment about a point, you need to know that the forces, the downward forces to the right are given clockwise movement. Clockwise movement means this force is pulling it down, is pulling this beam downward, and it wants to turn it in the clockwise direction, in the direction of the clock. Then we should also know that since the downward forces to the right pull it in clockwise movement, then we should know that the upward forces to the right as well will move it in an anti-clockwise direction. So what I'm trying to say is that this reaction here that is acting upward tend to push this beam upward. Pushing the beam upward means it wants to turn the beam in an anti-clockwise direction. So we should remember the principle of movement that says that total clockwise movement is equal to total anti-clockwise movement. So that is what we are going to apply now. So the total clockwise movement, we are taking, don't forget, we are taking moment about point A. So the total clockwise movement will be this force W here now. Don't forget our W, we have already calculated this as 100. So this force W multiplied by the distance from this support, because we are taking moment about this support A. So every distance must be measured from support A. So this moment, see this force W now and its perpendicular distance, because moment is force times perpendicular distance. So this force 100 Newton multiplied by the perpendicular distance from this support, and that is the distance x, and that will give us the clockwise movement. So we say W times x multiplied by x is equal to, now the anti-clockwise movement will be produced by this. Don't forget, because we are taking moment about this point, this 60 Newton will give us a zero moment. So we're not concerned about 60 Newton because we are taking moment about this point A. Similarly, if you are taking moment about point B, this 40 Newton will be irrelevant. It will be zero moment. So now, we are not using this 60 because we are taking moment about point A. But for this reaction at point B, it will give an anti-clockwise moment. So it's going to be the force at B, which is 40, multiplied by the distance from B to the support A, because we are taking moment about point A. So all distances must be measured from A. So the distance of B from A is 2 meters. That is the full distance. So we're going to say this 40, which is the force, multiplied by the distance, which is 2. Then we can now solve and obtain the value of x. Let's solve that first. So don't forget the weight is 100. So I have 100 multiplied by x, which is 100x, is equal to 40 multiplied by 2, which is 80. Now to get the value of x, we simply divide both sides by 100. 100 over 100. So this 100 will cancel 100. And we have x is equal to 80 divided by 100 will give us 0.8. And we are dealing with meters here. So that means the weight is acting as 0.8 meter from the support A. So you can see it now from this point. So the point through which the weight is acting is 0.8 meter, because the value of x is 0.8 meter. So the weight is acting at 0.8 meter from support A. And that gives us our final answer, because we have to find the point through which the weight acts. And that is 0.8 meter as the final answer. Hope you enjoyed this video. Please don't forget to like, share, and join for more videos. Thank you.